Welcome back. Last time I am talking about sequence. I defined sequence, nature of sequence, convergent sequence, monotone sequence, some theory based on sequence. Today I am going to discuss about interesting topic. At first, let's see one sequence. Minus 1 to the power n over n. Look the sequence. First term will be minus 1, then half, then 1/3, then 1/4, so on. If you observe carefully, then the sequence is neither increasing nor decreasing. It seems to be jumping. If you collect together all terms coming from odd xn, where n is odd, then I will get the sequence minus 1, minus 1/3, minus 1/5, so on. And this collection I can call it a new sequence. This is the concept of subsequence. What is subsequence? Let us take a sequence. Now, let me construct a sequence. X n1 equal to x2, x n2 equal to x4, x n3 equal to x6, so on. Okay? This is a new sequence, just even index. Okay? And this generate a new sequence out of this sequence. And this new sequence which generated its first term xn1, his first term x2, second term is x4, and third term is x6, and so on. Index of this sequence is n. But index of this new sequence is not n, is just k, where k equal to 1, 2, 3, so on. This is a new sequence called subsequence. There can be many sequences. What is nature of the subsequence? If I write xn1 equal to x2, and if I write xn2 equal to x6, then I can write xn3 equal to x4. Okay? The order which appears in this sequence, same order to maintain in this sequence. So, this is cannot be subsequence because it does not maintain the order of this sequence. That means this is not just a subset. Okay? It is something more. Here you have to maintain the order of the element. Okay? That means xnk is a subsequence of xn. then order of the element has to be maintained. Are you getting my point? Okay. Let's see definition of a subsequence. Given a sequence xn where n goes to 1 to infinity subset of R, then nk where k goes to 1 to infinity subset of natural number is an increasing sequences n1 strictly less than n2, n2 strictly less than n3, n3 strictly less than so on. Then the sequence ank is called subsequence. Okay? Alright. Let's see one sequence Sn equal to sin n pi over 2. Then what does it look like? This is a unit circle. Why? Because when n equal to 1, then the value will be sin pi by 2. And the value of sin pi by 2 is 1. When n equal to 2, then sin pi, the value of sin pi 0. When n equal to 3, then sin 3 pi by 2, the value of sin 3 pi by 2 equal to minus 1. That means, so this is a unit circle. What is the sequence look like? 1, 0, minus 1, 0, 1, 0, minus 1, 0, 1. Okay? And there is many subsequence. 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, minus 1. Many. Now, we choose a interesting subsequence. Choose Snk equal to 1, 1, 0, 0, 0, so on. That means 1, 1, 0, 0, 0, 0, so on. And notice this subsequence converging to 0. Even though the sequence Sn does not converging, but there is a convergent subsequence. And this is the link between bounded sequence and subsequence. Okay? Alright. Now my question, how a subsequence linked to be bounded sequence? If you choose some subsequence of bounded sequence, then what happens? Does the sequence converges? Here, one of the most important theorem has all mathematics. This is called Bolzano Weristrass Theorem. And this theorem is key fact of real analysis. This is also used in higher dimension. This theorem says every bounded sequence has a convergent subsequence. Okay? Here, at first, focus on the statement of the theorem. Here, every and a. That means, in bounded sequence, there exists at least one subsequence which is convergent. Okay? It does not tell every subsequence will convergent. Are you getting my point? Okay. By the way, this theorem is not true for unbounded sequence, because if you take Sn equal to n, then the sequence look like goes up, up, up and up. In fact, none of subsequence here converts to a finite number, okay? Because every subsequent must go to infinity here, alright? Okay. Before see the Bolzano Weristrass theorem, at first I will see very important theorem, the monotone subsequence theorem, which we will use in Bolzano Weristrass theorem. The statement of this theorem is every sequence an of real number has a monotonic subsequence ank. Okay? Let's consider this is a sequence. Look, here the statement every sequence but always has a monotonic subsequence. Look this sequence. This sequence is not monotone increasing or decreasing. But if you consider this red point, then this will be subsequence of this sequence, and this subsequence must be monotone decreasing subsequence. Are you getting my point? Okay. Now I will prove this Bolzano Weristrass theorem, and I will prove this theorem by using monotone subsequence theorem. Let's see the proof. Let Sn be a bounded sequence, because in statement has told every bounded sequence has a convergent subsequence. That means we have to prove this sequence has a convergent subsequence. Okay? Let Snk, this is case 1, be any increasing subsequence. Then since the main sequence is bounded sequence, then this sequence Snk must be bounded above. Okay? Therefore, by monotone convergent theorem, we can tell this subsequence Snk must be convergent. Okay? Case 2, if Snk is monotone decreasing subsequence of Sn, then Snk must be bounded below. Then similarly by monotone convergent theorem we can tell this monotone decreasing subsequence Snk must be convergent. Okay? That means always any bounded sequence has a convergent subsequence. Okay? Alright. Now my question, if a sequence is convergent, then what can you say about subsequence? Obviously it should be, because if an are closing to the value L, then part of that also should come inside L. Okay? That means the theorem is, if a sequence is convergent, then any subsequence of it converts to same limit. And this proof is so easy. Try to prove yourself. If you have any objection, then leave comment in my comment box. Okay? Now my question, can I say converse is true? Let's think it again. Let's look the sequence minus 1 to the power n. We know this sequence does not converge. Pick up the subsequence of even term. Then the subsequence converges to 1. If pick up the subsequence of odd term, then the subsequence also converges to minus 1. But suppose I put a condition, every subsequence has to converge the same limit, then the sequence must be converged. This is another theorem. If every subsequence converts to same limit, consider L, then the sequence must be converged to capital L. And this proof is so easy. Prove it yourself. Okay? If you want to understand when a statement is true, you should understand when a statement is false. And this is the fact of mathematics and life. Recall the definition. Sn converts to L. For all epsilon greater than 0, there exists n greater than 0 such that n strictly greater than n, then absolute value of Sn minus L strictly less than epsilon. This is the definition of convergent. Here small l. When a sequence be divergent, then the definition would be, here for all epsilon, here there is epsilon greater than 0 for all capital N such that n greater than capital N. This statement would be followed here. Here will be Sn, absolute value of Sn minus L strictly greater than equal to epsilon. Okay? Are you getting my point? Alright. Let's see previous example. Sn equal to minus 1 to the power n. And the term is 1 minus 1, 1 minus 1, so on. Let us consider epsilon equal to 1. Suppose n is given. Okay? Notice n plus 1 and n plus 2, which are greater than capital N. Okay, then what would happen? Absolute value of Sn plus 1 minus Sn plus 2 equal to minus 1 to the power n plus 1 minus 1 to the power n plus 2. This is always going to be 2, who is less than equal to, who is greater than equal to 1, and 1 equal to epsilon. So it's break the definition of convergent. So the sequence Sn equal to minus 1 to the power n is divergent. Since the sequence is divergent, so all subsequence, one subsequence 1 1 1, other minus 1 1 1 goes to different limit. If the sequence be convergent, then must be all subsequence goes to same limit. Okay, let's see one question of CSIR NET based on this property of the sequence. Let's first read the question. Suppose xn is a sequence of positive real numbers and let yn equal to xn over 1 plus xn, then which of the following is true? Option 1, xn is convergent if yn is convergent. Option 2, yn is bounded if xn is bounded. Option 3, yn is convergent if xn is convergent. Option 4, xn is bounded if yn is bounded. What I will do? I will take a counter example. Let's first see option 1. Here xn is convergent if yn is convergent. Let's take xn equal to n. Then what will be yn? Yn equal to xn over 1 plus xn. Then yn equal to n over 1 plus n. Okay, that imply 1 over 1 plus 1 over 1 plus 1 over n. Okay, and limit n tends to infinity, yn equal to 1. That means yn converts to y. Okay, but look, option 1, xn convergent if yn convergent. Here yn convergent, but xn equal to n does not convergent. So option 1 is wrong option. Are you getting my point? Okay. This example will use in fourth option. Here says xn is bounded if yn is bounded. We know every convergent sequence is bounded. Since yn is convergent, then yn must be bounded. Okay, but xn equal to n, who is not bounded. So option 4 also wrong option. Are you getting my point? Okay. Third option says yn is convergent if xn is convergent. Since xn is convergent, let's consider xn equal to a. And in question, xn is a sequence of positive real number. So L must be greater than equal to 0. And what is yn? Yn equal to xn over 1 plus xn. If we put the limit both sides, then limit n tends to infinity, yn equal to limit n tends to infinity xn over 1 plus xn. Since xn converges to L, if we apply limit, then this value will be L over 1 plus L. And since L greater than equal to 0, then this value will be well defined. Then yn must be converts to a limit. That means option third is true. Here given yn is convergent if xn is convergent. Okay. Second option says yn is bounded if xn is bounded. Okay. Yn equal to xn over 1 plus xn. Since xn is a sequence of positive real numbers, this is less than equal to xn for all n. And given xn is bounded, that means xn less than equal to a positive number m for all n. Therefore, from this line we can retain yn less than equal to capital M for all n. Therefore, yn must be bounded. Okay. So, option 2 also correct option. Are you getting my point? That means option 3 and option 2 are right option. Okay. Let's see another question of CSIR NET. If xn is a convergent sequence in R and yn is a bounded sequence in R, then we can conclude option 1, the sequence xn plus yn is convergent. Option 2, the sequence xn plus yn is bounded. Option 3, the sequence xn plus yn has no convergent subsequence. And option 4, the sequence xn plus yn has no bounded subsequence. Okay? Let's consider xn equal to 0 for all n belongs to natural number. Okay? And yn equal to minus 1 to the power n for all n belongs to natural number. Why we consider xn equal to 0? But because in question given xn is a convergent sequence in R and yn is a bounded sequence in R. Since this is a constant sequence, so this sequence always convergent. And this sequence does not convergent but is a bounded sequence. We all of us know. Here the sequence xn plus yn. Then the sequence xn plus yn will be minus 1 to the power n for all n belongs to natural number. And this sequence does not convergent. But if we consider two subsequences, first subsequence of even term, the value will be 1, and the subsequence of odd term, then the value will be minus 1. This sequence is constant sequence, so this subsequence must be convergent. This subsequence also constant sequence, so this is also convergent. That means both subsequences are convergent but main sequence is not convergent. Okay? And we all of us know the theorem. If a sequence converges to L, then all subsequence converges to same limit L. Here the subsequence converts different limit. So option 1 is wrong option. Okay, let's come back option 3. Here has told the sequence xn plus yn has no convergent subsequence. But see, the subsequence both are convergent, but the main sequence is not convergent. So option 3 also wrong option. Okay, and fourth option is the sequence xn plus yn has no bounded subsequence. This is convergent subsequence, this is convergent subsequence. We all of us know every convergent sequence is bounded. So this subsequence must be bounded. So option 4 also wrong option. Okay, that means option 2 is right. Let's verify option 2. Here given xn plus yn is bounded. At first, since the sequence xn is convergent, that means this is also bounded. That means the sequence absolute value of xn less than equal to m for all n belongs to natural number. And given yn is a bounded sequence in R, that means absolute value of yn less than equal to n for all n belongs to natural number. Okay, I have to prove xn plus yn is bounded. That means absolute value of xn plus yn less than equal to absolute value of xn plus absolute value of yn, which is less than equal to m plus n. This is a number for all n belongs to natural number. That means this sequence xn plus yn must be bounded sequence when xn and yn both be bounded sequence. So option 2 is always right option. Okay, all right.